Alright, welcome to our second video. As you can see, we're going to be doing section 3.3, first part, about quadratic functions and graphs. So similar to the linear equation stuff, we're going to talk about some characteristics, we're going to talk about some different forms and do a couple problems. Make sure to write down what you need, make sure to try the problems maybe before I do them. Like if you see me write down the stuff, try it out yourself. And let's jump into it. So, the parabola. Let's see. What does the function look like? Ax squared plus bx plus c, where a is not allowed to be 0, because if a is 0, we have a line. Characteristics. We have our parabola. Call this point down at the bottom or top. That is our vertex. Probably shouldn't have drawn it on this, but we have our axis of symmetry, that line that cuts through the center because it's symmetric on both sides. We have x-intercepts, we have our y-intercept, all things that a parabola might have. Let's talk about our parent function. Y equals ax squared. This is part of the function that really controls what it looks like. If the absolute value of a is greater than 1, so think about that for a second. That's like 2, 3, 4, or like -2, -3, -4. The parabola is going to be narrower. That's because you are stretching the y-coordinates. So these get taller, which means this way it looks skinnier. The absolute value of a, the coefficient of x squared, is less than 1, so you know you're -1/2, you're positive 0.2. Those numbers very close to 0. If the absolute value of a is less than 1, it's going to be wider, because you are squishing your y-coordinates. So if you take your parabola and squish it this way, it's going to get wider. If a is greater than 0, the parabola will open up. If a is less than 0, the parabola will open down. And I'm hoping that is review. We remember that. I guess I could say that the y-coordinate of the vertex is a minimum when it opens up. Now it makes sense, the vertex is at the bottom. Similarly, the y-coordinate of the vertex is a maximum if the parabola opens down, because the vertex is going to be at the top up there. Let's look at our standard form. Ax squared plus bx plus c. How can we tell where the y-intercept is? If you think back to our notes from Monday, how do we find a y-intercept? That's when x equals 0. Sorry, you can almost not see that. You plug in x equals 0 here, what are we left with? C. So c would be the y-intercept. Then how do we find our x-intercepts? That's when y equals 0. So we'd have 0 equals ax squared plus bx plus c. Got a couple options. Factoring if it's factorable. Quadratic formula. I hope we all have that one down. I'm not going to say it out loud, but I will write it. And then let's talk about the discriminant. Man, that was written poorly. The discriminant is the part of quadratic formula that's under the radical, b squared minus 4ac. If that is greater than 0, there are two x-intercepts. Positive square root, or excuse me, something positive under a square root will give us 2 solutions. If the stuff under the square root equals 0, means the square root equals 0, means we're only going to have one x-intercept or one solution, because this part goes away and it's just negative b over 2a. Finally, if it's less than 0, that means we're taking a square root of a negative number. So while we have imaginary or complex solutions, when we're looking at a graph on the real plane, we do not see any x-intercepts. Because take a square root of a negative number, you get some imaginary junk. All right, so that was standard form. Let's talk about vertex form. Y equals a times the quantity x minus h squared plus k. Why is it called vertex form? Because it tells you where the vertex is. The vertex is h comma k. Please notice the signs. We have a minus h in vertex form, so be careful for that. The axis of symmetry in vertex form, nice to find. It's the vertical line that goes through the vertex. So we just need x equals, and the x coordinate of that point is h. I guess I didn't say it for standard form. If you're in ax squared plus bx plus c, how do you find the axis of symmetry? I'm hoping you remember opposite of b over 2a. I'm guessing a lot of you will be taking calculus at some point in your life, and you'll figure out how a derivative will help you find that really fast. You won't have to memorize this. You'll just do it with math. All right, ladies and gentlemen, we're to the point where we're going to do a couple problems. They require some sketching, so forewarning you now, my graph drawing freehand is not that good, but we'll see how it goes. So the directions will be to find the vertex and axis of symmetry, and then sketch. So we're going to start with something in vertex form, -2 times the quantity x minus 1 squared plus 3. In vertex form, we will normally state the vertex first. There's our h, there's our k. Our vertex is 1, 3, no extra work needed. How nice. Axis of symmetry is the vertical line, so x equals goes through the vertex, so we need that x coordinate. X equals 1 is our axis of symmetry. I know it doesn't ask for it, but let's talk about the y-intercept. Y-intercept happens when x equals 0, so if you plugged in 0 there, thinking about order of operations, 0 minus 1 is -1, squared is +1, times -2 is -2, plus 3 is 1. So it needs to go through the point 0, 1. So when we're graphing, that's going to be helpful. Since this has a leading coefficient of -2, we know it opens down. And I don't know if it's got any nice x-intercepts. Let's sketch our graph. So, oh boy, I can already tell this is going to not be so great. So 1, 3 is where our vertex is. We know the y-intercept is at 0, 1. And since it's symmetric, we know if it goes left and down 2, it's got to go right and down 2. So we have our point 1, 3. We have our point 2, 1 and 0, 1. If you wanted to find 2 more points, I would plug in -1 or 3. So 2 squared is 4 times -2 is -8 plus 3 is -5. 1, 2, 3, 4, 5. Let's draw that down there. Let's draw that over there. Could be worse, right? Oh, missed. Rats. Decent graph. I'm guessing even from my sketch that it doesn't have nice x-intercepts. So we're not going to find those because we weren't asked for them. Number 2, we're going to start with something in standard form this time. So I'm going to actually find the axis of symmetry first for this one, because the axis of symmetry will help us find the vertex. So Oh, this looks like a B. I'm sorry. That's supposed to be a 6. So remember, we're going to do the opposite of B over 2A, which is the opposite of 6 over 2 times 3. So our axis of symmetry is at -1. How does that help us find our vertex? Well, they share similar x things. So the x-coordinate of the vertex is the same as that number, -1. And how do we find a y-coordinate? You plug in -1 into the function. Oops, that was not needed. -6, 3, -2 is a -5. I think it's -5. So there is our vertex. You know what? Let's do something fun for this one. Let's write this in vertex form. Once you've calculated the vertex, writing the equation for the parabola in vertex form actually isn't too bad. Y equals, maybe I should have used f of x. Oh well. X, instead of minus -1, let's do +1 squared minus 5. That sign stays the same for that one. And then what is the leading coefficient here? It's actually going to match that one. So that's what it would be in vertex form. Let's draw a sketch. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -5 is our vertex. We know our y-intercept will be our c value, -2. And with symmetry, I can draw over here at -2, -2, that point. So that's -2, -2. This one's 0, -2. This one's 1, -1, -5. If we wanted to find one more point, we can plug in 1. 3 plus 6 is 9, minus 2 is 7. Oh, I need to draw taller. And then using symmetry, go 1 and up to 7 on that side. The x-intercepts don't look nice, but since we're already in standard form, let's find the x-intercepts. Let's make sure we know how to do that. Let's find the x-intercepts. Since they're not nice, you probably cannot factor this nicely. Let's jump into quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's do some quick simplifying. -6 plus or minus 36. So that's going to be a plus because we have a minus and negative. 12, 24 over 6, which is -6 plus or minus the square root of 60 over 6. Now, do not be tempted to simplify quite yet. We have to simplify the radical. Beware, do not divide that 60 by 6. That is not going to be correct. 60 is 4 times 15. This is -6 plus or minus 2 root 15 when we take that square root. Now we can simplify it a little bit. Our x-intercepts are at -3 plus or minus the square root of 15 over 3, canceling a 2 out of those 3 places. So I probably went through that a little quick for some of you maybe. If so, go back, play a little slower, watch it a second time, see if it makes sense. All right, last problem. So write the equation of the quadratic function with a vertex of -2, 3, y-intercept at -1. And then let's write our final answer in standard form. If you're given a vertex, please start with vertex form. So y equals a times x minus h squared plus k. Let's plug in our vertex numbers for h and k for our x and y. So we're going to start with y equals a x. Instead of minus -2, let's write plus. So we got x plus 2 squared plus 3, but we still have this a. And how are we going to solve for a? Well, we're going to use our other given information. This is the point 0, -1. Let's plug in those values in for x and y so we can solve for a. Let's plug in -1 for y. Let's plug in 0 for x. 0 plus 2 is 2. 2 squared is 4. Subtract 3. And it looks like a is equal to -1. Now, this problem wants us to write it in standard form, so we need to expand. And I'm going to go through this, like everything else, quickly. Don't forget to distribute your negative sign to everything. Combine like terms for our final answer. All right. So we'll talk on Friday about whether we liked these, if this is better to do at home. Maybe I start doing half the notes for videos and then half the notes in class. We'll discuss what we like and what we don't. I just want to get a little bit more work and practice done in class, so we got to figure out a way how to do that. So thanks for watching. I'll see you on Friday. I hope the quiz went well. And yeah, enjoy your Thursday, because I won't see you.